Okay, so what we're doing is figuring out whether carbon tetrachloride is going to be polar or not. So we've got a sharing arrangement where we look at how we're going to share electrons to get the carbons and the chlorines to have 8 valence electrons, and then from that we draw the Lewis formula. Now you can draw a Lewis dot formula here. You could draw a Lewis formula, but you don't really need it to find the polar molecule, okay? Because you really can go from this Lewis dot formula a lot better to find in my opinion anyway, to find your three-dimensional structure, which is the next step. So all you do is look at that and count the number of shared pairs on here around the central atom. So I've got 1 shared pair, 2, 3, 4 shared pairs. And if we have 4 shared pairs, then you're not required to circle those. I just did it to show it to you. Yes?
Do we have to draw a line thing?
Which, this right here?
Yeah.
No. I'm saying you can't. But really, this is what you have to get your three-dimensional structure. All right, so from here, then we need to do a three-dimensional structure that has 4 sets of electrons that's spaced equally around the central atom as far apart as you can get them. And the shape that gives you that is a tetrahedral. Okay? So you put this line perfectly vertical. And this line is more than 90 degrees. That's 90, a little less than 120. So you're right there. And then over here, you're doing kind of the same thing, only they're kind of grouped together. Okay? So since I've kind of got some stray marks, I'm going to do that here. Straight up and down.
The dash line has to be on top.
No.
Oh.
But I like to put it on top. Okay? Then you got to have one more than 90, less than 120. And you could do that over here. It doesn't matter which side these go on. So this can go right here. Then you want a triangle here and a dotted line there. Okay? And you put your sets of electrons on these arms. This is where we get VSEPR, Vesiper, valence shell, electron pair repulsion. Those pairs of electrons push apart from each other. Okay? Just like when we put our balloon models together, the balloons could only get so close together and they stop. So they're pushing apart just like our electrons are in a sense, kind of like our electrons are pushing apart. Okay? Once we've got that, then we can get the next step, which is to take in any place you've got sets of electrons that are shared, replace them with the atoms. In this case, all the electrons around the central atom are shared. So all 4 of these are shared. So all 4 of these right here are going to become shared here. Now I'll lay my pencil down someplace, I guess. So we're going to redraw exactly the same drawing with our electron dots on here. But we're going to go back then and replace the electron dots with the atoms where they belong. So in this case, all 4 of these arms have chlorines on them. So we're going to put chlorines on all 4 of these arms. Now once all the electron pairs are gone, then you have a molecular shape. So this is a tetrahedral electron pair shape. This is a tetrahedral molecular shape. Tetrahedral refers to the geometry, like a circle or a square is geometry. Okay? This is not three-dimensional. These 2 drawings are. This is 2-dimensional. This is a Lewis formula. Okay? It's not three-dimensional. All right. From this, then, I can determine if the molecule is going to be polar. However, I don't have to do any math in this case because you have to have 2 conditions to know a molecule is polar. Okay? The 2 conditions are you must have an uneven distribution of bonds. Okay, that's the first condition. It's a 2-part rule. You've got to have both or it's not polar. Okay? Well, tetrahedral molecular shapes are not uneven, so long as all the atoms on the outside are the same. Everybody get all that? Tetrahedral shapes are not uneven in bonds. They're evenly spaced. All of these bonds are 109.5 degrees apart.
So tetrahedrals are not.
As so long as all these atoms out here are the same. And I'm going to show you what I mean by that in just a minute.
Did you say tetrahedrals are all not uneven?
No, a tetrahedral molecular shape is always even in distribution of bonds. Okay? If all these atoms on the outside are the same. Okay? Alright, and so since we have to have uneven distribution and we have to have polar bonds in order to get a polar molecule, either one of those conditions will make it nonpolar. Since it's even instead of uneven, that has to be a nonpolar molecule. We don't even have to do the math. Don't even have to do the math. Yes?
Okay. I understand this, but when it comes down to the one at the top, like the straight line, and then molecule shape. No, not them. I'm talking about on this sheet.
Okay, that. All right, so he's referring to the unit handout. What page is that?
21.
Okay. All right, page 21 on your unit handout. If you're not getting that out, you're planning to fail the test. Okay? Because preparing to fail is preparing. Failure to practice is practicing to fail. That's right. Good. Thank you. I know it. I had it all messed up. You're right. I bet guys in football and baseball and stuff, you've heard something like that somewhere. Perfect practice makes perfect results or something, things like that. Practice makes perfect. Okay. All right. All right. Now, what's your question here? I'm sorry. Go ahead.
The three at the top and the other three. I mean, like first row and second row, those ones, and then on the third row, the second and the third. Those are all confusing.
Okay. Well, we're about to get to this stuff right here. Okay, we haven't gotten to what this means right here yet.
Do you have to ever worry about bent molecule shape?
Say again?
Bent molecule shape?
Sure. Water's bent. Bent ones you have to worry about, yes.
No, I'm like, how do you know exactly
How do you know when it's bent?
Yeah, can you give an example?
Sure, I can do that. Okay. All right. So if you'll look, while we're here though, since we're on this page, okay, let's look. This is an illustration that's like the one we just did, the molecule we just did. Okay? And the molecule we just did, move it over here so you can see, the central atom here is A. All four of these are the same, just like all these B atoms are the same. Okay? So this is a tetrahedral shape, and it's saying up here that so long as you have that kind of shape where all the outlying atoms are exactly the same, then it's going to be nonpolar. Okay? That's just a help for you. All right? The same is true if you get trigonal planar. If all the outlying atoms are the same, then the molecule has to be nonpolar. If you have a linear molecule, so long as both this atom and this atom are the same, then you're going to have a nonpolar molecule, regardless of whether the bonds are polar or not. Okay? Well, it goes straight through. Carbon dioxide is a straight line. Okay? And we did that one. That was in the last unit handout. Okay? It shows you how to make that one. So here's a bent molecular shape. Okay? Now this is going to be polar if the bonds are polar. That's what it says right here. If you have polar bonds, the molecule's polar. Polar bonds will give you a polar molecule. If it's bent or trigonal pyramidal. And this is also bent here, so you get the same thing. Now, in this class, in a CP chemistry class, we don't worry about these shapes down here. We're not going to get that deep. You may need that when you go to college. In fact, I'm sure you will need it when you go to college. But for right now, in this class, these shapes you don't need. That make sense? All right.